Hello and welcome to Unit 3, Day 2. Zeros, relative max and min, intervals of increasing, decreasing. The whole beginning of this is going to be super easy. It's a lot of review that we've been doing and talking about all through Unit 1 and 2. Okay, the zeros are the points that intersect the x-axis. They're called zeros because that's where f of x equals 0, meaning that's where the y equals 0. This is the x-axis. Y equals 1, y equals 2, y equals -1, y equals -2, y equals 0 here. So everywhere along here, that is when y equals 0, and y we know is the same thing as f of x. Okay? So they're called zeros, they're called roots, they're called x-intercepts. We've talked all about this. They're called solutions. Okay? The degree is the same as the number of zeros most of the time. Okay, they say most because sometimes we have something called a non-real zero or an imaginary zero, which we briefly discuss here. That's when you have to take the square root of a negative number, and that's a whole unit in itself, so we'll get more involved in that later. Okay, so we have discussed this before. If I tell you that something has a third degree, then you're going to get 3 roots. If something has a fourth degree, you're going to have 4 roots, and so on. Okay? An odd degree must have at least 1 0. Why? Well, what did we talk about with an odd degree? An odd degree means it starts low and ends high, or it starts high and ends low. Well, regardless, if we're starting at the top and moving to the bottom, or starting at the bottom and moving to the top, didn't you have to go through the x-axis? And if you have to go through the x-axis, then you must have at least 1 real root. Okay? The number of zeros of a polynomial, both real and imaginary, that's what we were talking about a moment ago, is equal to the degree. Okay, so we've said this so many times now. If something has x to the 7th, you're going to have 7 roots. Okay, so here I have a degree of 4, so what do we see? 4 roots. 1, 2, 3, 4. And they just gave you ones that were decimals so that you don't think that they're always integers. Okay, sometimes they're decimals, sometimes they are irrational decimals. We've done those last unit, you know, like 2 plus the square root of 3. Okay, so this 5th degree polynomial has 3 zeros, but only, has 5 zeros, but only 3 of them are real. Therefore, the other 2 must be imaginary. How do you know this is an odd degree? Well, it's an odd degree because it has end behavior that goes opposite directions. Remember, that always means an odd degree. So this is going up and it's going down. That's telling you have an odd degree. Okay? So they're trying to show you there's a little bit of a wiggle in there. That little bit of a wiggle or where the other imaginary roots are. Okay? So right now we have 1 root that is -2. We have another root that is +1 and another root that is 2. So that would give me f of x equals x plus 2, right? Always opposite. X minus 1 and x minus 2. Well, that's only a 3rd degree, right? X times x times x, or 3 roots. They're telling you it is a 5th degree. So that means there must be some other root in here that has 2 more roots. Technically, it counts twice. Okay, so if you look very, very faintly, you could see the 1, 2, 3 that we just said, and they told you what the other root was. They told you it was x squared plus 1. That's not something that you would come up with. That's something that would be given to you, so don't worry about that, okay? So this, remember when we were doing it earlier, we would just put 2QF because we would have to use the quadratic formula to get that, okay? So now I have 2, 3, 4, 5, and that's when this will change to a 5th degree, okay? That seemed a little harder than it really will be because they're having you kind of look at it for the first time, okay? So let's take a look at this one. A vertex on the x-axis means there's multiple zeros, okay? So it's occurring more than that, more than the one time. So if you notice, it's not cutting through, it's bouncing. It's hitting it and bouncing away. That's called a bounce. It's also called tangent, if you remember from geometry. When something just touches and goes away, it's called tangent. That bounce or tangency means that it has multiplicity of 2. It counts twice. If it flattens more as it's there, then that could be a multiplicity of 4 or a multiplicity of 6. Okay, it's just going to keep going up by 2s. So if it bounces, it could be 2, it could be 4, it could be 6, and so on. Okay? All these extras, or if it bounces and gets a little bit flat, bounces and gets a little bit flat. Okay? So once you see a bounce, you know it is definitely going to count an even number of times. So here's a bounce, here's a bounce. Okay, so that's explained over here. And you could come up with that equation. F of x is equal to, I have a root at -2, so that's x plus 2, and it bounced, so it counts twice. That's of least degree. It could have counted 4 times, 6 times, whatever. But at least degree, it's that. And then your other root was 2, so that's an x minus 2 factor, and again it bounced, so we counted twice. If you put that in your graphing calculator, that's what you're going to see. Okay, next one. This printed extremely light, so f of x is equal to x minus 1 squared times x minus 3 times x plus 2 squared. Okay, so that means x minus 1 is a factor that counts twice because x minus 1 squared would give me x equals 1 multiplicity of 2, which means it's going to bounce. Okay, then x minus 3 means x equals 3, but it's a multiplicity of just 1 because there was no exponent. So that means it just cuts through the graph. And then the next one, x plus 2 squared, gives me a root of -2 with a multiplicity of 2, which again means it bounces. Whoops. Okay, so we do notice that the leading coefficient is a positive because there's nothing there. So if my leading coefficient is positive, and I have a total of 2 plus 1 plus 2, the degree must be 5. So a positive 5 starts low, ends high, right? Goes opposite directions for being odd. Positive means we start low, go high. So I would put a root here, here, and here from all of this. I would start low. As I go up, I would bounce off of that because it counted twice. And then I would have to come back, bounce off of that because it counted twice. And then I'd have to come along and cut through. Okay? Now, you can always check yourself because you can type that right in the calculator. And you'll see this. And, of course, these should have arrows. Okay? So, this, again, is just kind of giving you a little summary of how to do repeating zeros. Okay? Don't worry about this part of it. This is what I was saying over here. If something appears to flatten It just raises the multiplicity. Whoops, oh my goodness, I can't spell for a second. Multiplicity, okay? So if something cuts, it counts once. If it cuts and flattens, it counts 3. Once I start saying flatten. If it cuts and flattens, 5. Cuts and flattens, 7. If it bounces, it's twice. If it then gets flatter as it does that, it's 4, it's 6, it's 8, and so on. That's what that's trying to explain. Okay? So here's the bounce, also called a kiss. You can read through that. We don't use the word kiss, we just say it bounces. Okay? Here you can read through this one. If it cuts, there's it cutting, but it's not cutting straight, so it's not a 1. The second there's a little bit of a flattening as it cuts, then it's 3. If it flattens even more, then it would be 5. Flattens even more, then it'll be 7. Okay, so I explain that in a little summary right here. You should be able to follow through. Okay. So pause this, rewind it, go back, look over anything that you feel you didn't quite understand from this lesson. And then we'll start going through these. The first example, they're asking you to tell me the name of this. Well, you could put this in the calculator and see if it looks like this. Put this in the calculator, see if it looks like this. If you ever get stuck, okay? Or you see, I know this is very hard to see, but -1 is a bounce. That means I should have an x plus 1, remember opposite, squared, okay? So an x plus 1 squared. Well, immediately over here, I can eliminate this because this x plus 1 is not squared, and this x plus 1 is cubed. Here, this is +1, which means it gives me an x minus 1, and it started high and ended low, which means it cut through, and it flattened when it cut. So if it just cuts, it's once, but if it flattens when it cuts, it goes to 3 or 5 or 7, any odd number, okay? So x minus 1 to the third. X minus 1 to the third, nope, but here's x minus 1 to the third. So that must be the answer choice, but then double check with this. Right here, that is a 2, and it just cut. So that would be x minus 2. And again, you can always check that in the calculator to make sure. Okay? So you can do number 2. I know it's kind of hard to see this, but this was a 1 and a -1, sorry, and it bounced. Then it bounced on 0. Okay, then it cut at 2, and it bounced on 3. So that should help you with that one. Okay, number 3, you should be able to do the sketch of it, realizing there's a positive leading coefficient because there's nothing there. And if this is a 1 and this is a 2, the degree is odd. So think of your end behavior. Positive odd should look like this. You have a root with a bounce. Okay? So try that one on your own. And then increasing and decreasing, you did this in Algebra 1, and you probably maybe don't remember it too much, but when we're talking about increasing and decreasing functions, it's when you are reading your graph from left to right, like you read the paper, okay? So as I go from left to right, just trace your finger along, or your pen along. As I go from the left to the right, what's happening? It's going up. So if it's going up, it's an increasing. As I trace from left to right, it's going down, so it's decreasing. Okay, so here we're going to describe these intervals. Intervals, because we just said it's when I'm reading the page from left to right. The only axis that goes from left to right is the x-axis. So when they're talking about intervals, they want the domain. Domain is the x values, okay? So right now, describe the intervals that are increasing. Well, if I start way to the left, as I'm going along, I'm going up this whole time until I hit -3. So if this is going on forever, this is negative infinity. So from negative infinity up to -3, I have been increasing the whole time. Okay? Then all of a sudden I'm going down until I hit right here at 1. So decreasing would be from -3 to -1. I'm sorry, +1. From -3 to +1, it's going down. Then it starts to go back up again until I hit 4. So from 1 to 4. 1 to 4, I'm increasing. Then right here, it's just constant. It's horizontal. So that's yet another thing that they ask about. You are either increasing, decreasing, or constant. So the x value is 4, and then it had an arrow, so 4 to infinity is when it is constant. So it was increasing, decreasing, increasing, constant. Okay? And whenever they ask about increasing, decreasing, or constant, your interval notation is always done in parentheses, never brackets. Whether it's an open circle or closed, don't ever worry about it. Okay? All right, and then this part is from Algebra 1, maximums and minimums. You know the maximum and minimum. If it turns up here, that's a maximum. Then it swoops below and turns, that's a minimum. That's the maximum part, that's the minimum part. It's the top, the bottom, right? The high, the low, another high, another low. Okay? They're called relative because there are higher points if this is going on forever. Okay? There are absolute maximums, those would be the highest. But if you notice, this was the same height, and this was the same height, so they're called relative. If this all of a sudden turned up here and came back down, then this point would be the absolute maxima, or maximum, because it's the absolute highest. These are the relative. Okay? All right, that's it. We're into the classwork. Almost 18 minutes again. Okay, so these you should be able to go through. And if not, remember, I always come back in and we go through little bits of the lesson. I'll show it to you all over again, answer any questions that you might have. And then in class, you'll work on these together in groups, and I'll come around and I will help you get through each of these in class. Okay? Let's see. Yep, you only have 5. Okay? Have a great day. Bye.